The last thing that we're going to talk about is dividing rational expressions, which is funny because we really don't actually divide fractions. We just turn them into multiplication. But you can't just do that for free. There's a consequence. Whenever you turn division into multiplication, it results in having to flip whatever fraction you were dividing by. So that's what this tip of the day is. Whenever we actually do division, we're going to turn it into multiplication. And it's going to be keep the first fraction, change the division to multiplication. Can't do that for free, so it ends up flipping the last fraction. So let's take a look. So it's called keep, change, flip, KCF. So let's write that on top here. KCF. So that means we're going to keep the first fraction as x cubed y squared over 10x squared y to the fourth. We're going to change the division to multiplication. So it's going to turn into multiplication. And that second fraction, we're going to do the F. We're going to flip it upside down. So the thing that we were dividing by, we're going to flip that upside down. So it becomes 5y to the 6th over 8x to the 4th y squared. So we don't actually end up doing any division. We just turn it back into multiplication, which means factor if you can, then start canceling. There's nothing to factor here, so we just start canceling and reducing. Well, notice we'd start with the numbers. 5 and 10 are both divisible by 5, so that would leave us with a 1 and a 2. Be careful. You cannot reduce the 2 and the 8 because they're both on the bottom. They would just be multiplied straight across to get 16 because they're both on the bottom. The 16 would be on the bottom as well. The next thing you would go after is reducing, let's say, the x's. So first off, I'd say, well, I can reduce the 2 x's on the bottom of the first fraction with 2 out of 3 on the top. But I can still also reduce one more x from the last fraction. Notice there were 3 on the bottom of the last one. 4 on the bottom. If I reduce 1 out, it will leave me with 3. That will cancel out the one remaining one on the top. So notice that does leave me with 3 x's left over on the bottom. Next, let's go after the y's. Notice I do have 2 y squareds that are completely by themselves on both the top and the bottom, so I can just cancel those out directly and quickly. But I also do have a y to the 4th on the bottom still, and a y to the 6th on the top, so I can reduce 4 more y's. So if I cancel out the 4 y's on the bottom with 4 out of 6 from the top, that leaves me with 2 extra y's, but notice they are on the top. So my final answer is that I'm left with 2 y's on top, 3 x's on the bottom, and 8 times 2 gives me 16 on the bottom as well. And that is my final answer, and it is already reduced because there are no common factors between the top and the bottom left over. Next time, again, I see division, so I'm going to do my keep, change, flip again. We keep the first fraction, which is x plus 7 squared over x plus 7. Remember, we're going to change the division to multiplication. That can't happen for free, so there's a consequence. It flips that second fraction upside down. So when it flips it upside down, it becomes an x plus 7 over an x minus 3 squared. Now, a good thing to remember is, what does it mean for something to be squared? It means there's 2 identical copies. I always think of them as twins. So when we see this first, x plus 7 squared, we should be thinking that what that means is that there are 2 copies of x plus 7 up there. So that means I can't cancel out the 2 squareds. The squared on top means I've got 2x plus 7s. The squared on the bottom means I've got 2x minus 3s. What it does mean is that I can cancel out one of the x plus 7s on the top with one of the x plus 7s on the bottom. So I'll cancel out one of the two on top with one of the x plus 7s on the bottom. Notice what that means. It means I still have plenty of stuff left over. I've still got an x plus 7 on the top of one and an x plus 7 on the top of the other. So when they get multiplied together, I'll still have two x plus 7s on the top, which means I can still keep them as squared. And I still have an x minus 3 squared on the bottom. Again, this is saying I've got two x plus 7s on the top and two x minus 3s on the bottom. They are not identical, so they cannot be canceled. That is your final answer. It's completely reduced as is. Moving to C. Again, whenever we're doing division, get used to it's keep, change, flip. Keep the first fraction as y times y plus 2 over y squared, y minus 3. Again, we're going to change the division to multiplication. Again, that doesn't happen for free. It's going to flip that second fraction upside down, so it'll become y minus 3 squared over y squared times y plus 2. So notice, though, what is really nice is it's already factored. So we can just jump to canceling. Had it not been factored, we would factor it right now. So what is already factored, that's identical that we can cancel out, is a y plus 2 from the top and the bottom. We also have one copy of y minus 3 we can cancel out. So I can cancel out the y minus 3 from the top with one of the y minus 3s on the bottom. We can also cancel out one y on top with one of there's 4 of them on the bottom, one of the y's on the bottom. And I think that looks like it. That leaves us with one remaining y minus 3 on top. And be careful, let's see what's left on the bottom. We have a y and a y squared, which means we've got a total of y cubed on the bottom. So we've got a total of 3 y's on the bottom, y cubed. So there's our final answer. Here's our last problem. Notice it's not factored, but we don't want to do that yet. We want to get into the habit of doing keep, change, flip first. So let's do our keep, change, flip first because we have division. So we keep the first fraction. Then we turn the division into, we're going to turn the division into multiplication, which just like before is going to cause us to flip that last fraction upside down, which makes it x plus 3 over x minus 3. Now let's factor, and then we'll cancel and reduce. So factoring, well, only, let's see, the top of the first fraction can factor. It factors as a difference of 2 squares of x plus 3, x minus 3. And the bottom of the first fraction also factors. We've got a common factor of 5, which, if factored out, will leave you with also an x plus 3. Don't forget, we can't ignore that second fraction. Even though it can't be factored, we still have an x plus 3 and an x minus 3 on our second fraction. So now we can see, now that everything is factored, what can actually cancel. Notice we can cancel out an x plus 3 from the top and the bottom. And we can also cancel out a factor of x minus 3 on the top and the bottom, which leaves us with our leftover factors of x plus 3 over 5, and that is our final answer. So what we can see as a summary is sometimes our problems come factored, sometimes they don't. But in order to do any of our problems, our final answers for our fractions must be reduced, which means we have to factor it and cancel out any identical factors between the numerator and the denominator.